Here we are again, getting ready for day three of 2021 Advent of Code. Um, I guess we should look back on how day two went. So, um, in terms of the programming side of things, I guess the biggest thing looking at yesterday's code is we used this parse lines function, which probably wasn't necessary. Just using a split on the space would have been good enough. But I don't think that was a mistake. I do think marshaling the input when we first got it um, would have been better in a lot of ways. It's not just the kind of general engineering thing of don't repeat yourself, but just in terms of programming competition, you know, a third of the code down here is just this marshaling, all this crap. And what's more, it's not just the number of characters; they're ugly characters. It's the line noise stuff. It's the reason I don't like to use Perl. So it would be nice to get that to off to one place. So really, what I should have done on the input is something like this, because the input looked something like that, and I should have just thrown on a map that turned it into a tuple, right? And then I could access the second thing. Actually, these would have been optionals, wouldn't they, when I got them? So there'd be an extra exclamation point in that int expression. And then I could access the members of the tuple, even if they were unnamed members. So I think I'd do that differently if I had day two to do over again. Um, there's also a little. I have never made these videos before, and yesterday in particular, when it was happening, I was hoping it wasn't noticeable, but rewatching, I saw it. Just being on camera, my fingers were actually shaking as I was typing the keys, and I guess that's a little bit of just nerves, knowing that someone is watching you doing something. And I can't remember being nervous typing um, since the very first time I was, working at some multi-billion-dollar company with a project that had some responsibility, and there was a major outage, and my team was in the stack trace, and so three very, very important people ran over to my desk and stood behind me until I could explain to them what was going on. And, it turned out it was some other team had a bug in their code or whatever, but I had to point them at the correct team and say what was going wrong and everything. And I remember in that situation also being very thrown. But that happened a couple more times at that company, and I was not so nervous about it. So that's just one of those things. Um, and there's the whole thing about how much should I be talking when I'm doing this. Let's just make sure we have some time. Yeah, we're good. Um, the first few problems are completely trivial, so it's kind of hard to know what to say because all the programming is utterly uninteresting. Um, but I think I'm going to have to practice doing that because it maybe slows me down or kind of gets me out of my head or whatever. But I'm going to need to get better at that. And finally, I yesterday some of my windows were overlapping with the camera window, so yeah, we should do better at that today, I hope. Okay, so enough reflecting. And that was yesterday's. This is just what I put together for today, but who knows what the input is going to look like today. It might not be a column of numbers. So it might be more interesting than that. And I guess we should. Oh, yeah, so you see, if we'd done that, we'd get these tuples, and then we could access them with we do a for loop over each of these things, and we can access like the numbers, by the tuple index. Anyway, so let's get this set up to run. Oh no, what do I call it? Yeah, I call the thing 2.swift, and then what I should remember to do is copy 2.swift to a file named 1.swift once I've done with part 1 is kind of my system, but I don't always remember to do that. I have to use my undo buffer to catch it. Okay, so let's see what day 3 has for us. Binary numbers, okay. So we probably are going to parse Numbers? No, we're going to parse strings, I think. So we don't want to do this mapping. We're just going to take the strings. The most common bit in the corresponding position. There are 5 zeros. The first bit of each number. Most common second. Okay. I see what you mean. So, okay, let's look at our input. So there are only going to be about a dozen of these things. So that's fine. We'll save that as a text file. So, what are we doing? Six, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. No, let's actually find out how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So, how many do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, yeah, we don't need those last 4. Okay. Right. So, now, for string, for each string. Can you iterate over strings? You can, right? Okay, now I'm not actually sure how I'm going to count these up, but what am I actually trying to get here? Considering the most common, so the gamma rate is the binary, okay, the epsilon, the least common bit, so that should be just the inverse of the first one. Okay, so if we get the first one, we can get the second. To calculate the gamma and epsilon, then multiply them together. So then we have to convert this thing to a binary number. Blah, blah, blah. So let's do the conversion to a binary number. Okay, how many numbers? Okay, so we know we're going to have a number of bits equal to the number of things in data, so we're going to actually just keep the count of the number of ones, and then the number of zeros will be the number of things in data minus that, so we can tell what the most common thing is. Right. Okay, so great. We are not going very quickly tonight, so no leaderboard for me. Okay. Let's just see if this compiles. Yep, okay. It compiles. Now, and higher, so if P is greater than and then it's a 1, so we say F's by 2 as well. And I don't know if I've forgotten all the logic, but let's print both of those out. And I think that third one is what we actually want to find. Oh, so 0, so gamma is not good. Data count over 2. Not the U. Over 2. Well, those both look like reasonable numbers, so let's give it a try. Yeah, okay, let's go on. And I was 948, which is better than before. So now let's actually copy this, because this is what I normally do. Okay, good. Next. I don't know what a bit criteria is. Most. Okay. Well, I like that it's a little more complicated. So this is good. I think we're gonna turn it, because I think we're gonna have to call this a bunch of times. Count ones in, what is it? Data, it's gonna be an array of strings, right? Oh, and it's gonna be an array of ints. Okay. Okay, so we know how to do that. The bit depends on which type of writing you want to find. Keep only numbers with that bit. What is the current? I gotta read this again. I'm sorry. Start with the full list. Then keep only. Consider the next. Okay, so we filter based on the first one. Okay, so so we say the criteria count ones in the data. Data equals data filter. Zero. Okay. Oh, the Carpause and Carpet are the same damn thing, aren't they? Oh no, they're not. Yeah. Um. Um. V credit. Greater than. Then it's a 1, otherwise it's a 0, right? And we're going to have to do the opposite for the other thing. Okay, keep only if you, this is the rating value. So, because we got to preserve the O data. And then we got to do all this again, but with everything backwards, right? Not everything, but okay. Do that. Just this part. But first we have to data equals O data. There we go. Rating B. Okay. Then what? Finally, multiply by the, yeah. Oh, multiply the 2, so, no, let's, gamma and X. Ooh. Oh. None of that is right. Okay, so let's. Not the most elegant way to verify that this is all working as I expect, but that's fine. Okay, so print. We have here. So why is this an error? Oh, because I'm Pythoning it. Okay. Okay. What doesn't compile about this? A whole bunch of stuff. Oh, data, yes, of course. Actually, that's a let. What else do we have? whole bunch of stuff. Oh, I hate this about Swift. Count ones. Let's just stringify it. And unfortunately, this is what you get when you do copy and paste reuse if you haven't compiled it yet, because you're going to have to fix the same bug in multiple places. Come on, what is this? String, what is, count ones takes, what? So how did that know? I don't know, I misunderstood my first message, sorry. We're gonna have to actually pay attention to this, because I'm not doing well. Cannot convert an array of substrings to strings. So, lines. This is vaguely applying one of my lessons from the reflection. Ambiguous carbit. Okay. 34. What is this? Why is that ambiguous? 31 and 42. Oh, because I defined 2 at the top level. Am I allowed to just introduce this, an arbitrary scope? I don't know if Swift lets you just introduce scopes like that. Let's find out. I don't like that. No, not really. I'm not enjoying this. Carbit. If you're going to do that kind of hack, always do it on the first one, because otherwise you'll forget. And anyway, character and int, that seems fair. Carbit. Okay. So the data is strings. Strings is v. So these should be strings. Same down here. What? Oh, God. I don't know if this is actually solving the problem. See, I have added a you can look up by index, but yeah. Cannot find gamma. So we're down to 41. Okay, so that does seem to have worked. So, and that. I can walk through exactly what this converting to character magic is and what the errors were. So remind me, but you can't because that's not how videos work. Crit was never modified. Yeah. Binary operator. Okay, 60 from binary. Oh, why didn't it tell me? Yeah. Okay. Well, that's a number. Let's see if it's right. No, it's not. Brilliant. Sigh. Okay. So we might as well use, they have to start with all 12 numbers. All 12 numbers. Okay. So. Oh, how do you do vertical everything's in BBEdit? There is a way, but I don't know what it is. So that's a shame because I gotta waste all this time doing this to get my test data in here. Oh, and I forgot my commas. Okay, so, well, first let's just run that. Oh, and there's an error. Is there? Invalid redeclare. Oh, yeah, because we don't want to bar it. We can just reset it. Okay. We should print out these things so we can follow along. We might as well get rid of these stupid. Okay, so first, so for example, start with all 12s, then 4th and 5th, so we end up with 10111. Oh, but we don't. So we get this wrong. So let's actually let's print our data each time we go through this. So all of them. Oh, sorry, I'm obscuring my camera again. I promised I wouldn't do that. Okay. Start with all 12. No, start with all 12. So keep only the 7 with 1s in the first position. 1, 2, 3, 4, 5, 6, 7. That looks good to me. Second bit, there are more zeros. So 1, 0. So there are 4 of those. That looks good. Third, have a 1. So keep the 3. 1, 2, 3. Yeah. Fourth, 2 of them have a 1. Yep. In the fifth, an equal. Keep the number with a 1. Oh, I missed the rule for them being equal. So is greater than or equal to. And I'm guessing if that's the rule, then it's the same rule down there. So let's try that again. So now we got 11110. That's not right at all. What? Okay, well, I'm lost. So we want only ones, and then we actually want a 0 in the second position, but now that's not right. What? The second bit, there are more zeros. 1 bits. So I think this is actually more of a, oh, we shouldn't do it here. +1/2. Let's just see if that works for the first. Okay, 4, 10101. This is driving me crazy. Stupid off by 1 errors. I'm an idiot. Third position. 3 of the 4 have a 1, so keep the 1. Fourth position. No, this is the third position, isn't it? 101, 101, 10. Filtered on 1, 0. So a 4 with 1 zeros. The third, 101, 101, 101. Right. And the fourth, 2 of the 3 numbers. 1, yes. Why? So we have 2, 4. So this is just flailing at the off by 1 errors instead of actually working out the logic, really. You could do this with machine learning a lot better. So, okay, let's assume that that's the right way to do things, because okay. Okay, 01, and then the second one is 01010, yes. And the result is 230, yes. Okay, so let's try it with the real data, shall we? That looks suspiciously similar to the number I put in before. Well, okay. Yeah. I mean, I'm sure we were nowhere close to the leaderboard, particularly on the second part. So, how did I do on this one? Better on the first half, I guess. I tend to do better as the problems get harder, but still nowhere near the leaderboard. But we all saw the flailing, and man, that was half an hour. That's pretty embarrassing. I did promise I would explain one thing that's really just a detail of my own silly little library. So here, my library, in Swift, you can't index a string by integer, which is incredibly cumbersome. So I wrote a utility that allows you to index a string by integer, and that's just you get a string index, which is an opaque type, and then you offset it a certain number of character positions from the beginning, and then you index by that. So that's what this is doing here. But of course, that returns you a character, not a string. And if you just enclose something in double quotes, it's a string. So then it's trying to compare a string and a character, and the types don't line up. So that's why I turned those into characters to make it all work. Anyway, well, quite an awkward day, I guess, with a lot of off by 1 errors and everything, but and not much that's terribly interesting, algorithmically at least. But we got through it, so I guess I'll see you tomorrow.